Assalamualaikum to Dr. Amir. Today I want to present about mini project for subject digital signal processing, which is design a 3/3 order digital low pass Butterworth filter with a cutoff frequency of 2374 Hz with a passband ripple of a 3 dB at a sampling frequency of 10 Hz. So with that, I need to determine the transfer function and different equation. We also use Scilab or MATLAB software to plot the magnitude and phase frequency response and draw the block diagram of realization in Form 2. With that, from the offset plane, determine the system of the following criteria, which is region of convergence and the stability of the system. So for determine the transfer function and different equation, we need to use cutoff frequency, which is Fp 2374 Hz, which is my last 4-digit ID metric number, and Fs is 10,000 Hz. With the passband 3 dB. For the step 1, we need to identify the T, which is time 1 over Fs. So first is we need to 1 divided with Fs, which is 10,000, it will get 100 microsecond. After that, we need to identify WAP, which is equals to 2 pi F, and we need for the F we need to put our 4-digit metric number, which is 2374, and finally we will get 40.92 kilo. After that, there also a equation for WAP, which is 2 divided by T and times with tan. WAP will times with time and divided by 2, which is shown in this. So that after getting the value for time and after getting the value for time, we can calculate the value and which will get 80.48 kilo. And for the transfer function, we can use this equation, which Hs with which is similar to S per WAP, which is 1 per SWAP power of 3, and 2 will times with SWAP power of 2 and plus with 2 times SWAP with power of 1, and finally with plus with 1, and all this will times with WAP power of 3. And with simplifying the equation given, which is the formula, I get WAP power of 3 will divide it with S power of 3 plus 2 WAP S power of 2 with plus 2 WAP power of 2 times S, and finally plus with WAP power of 3. So we need to use WAP power of 3, which is WAP answer, which is 80.48K, and after include the WAP result, we need to make a calculation, which we will get in this 6.31T, which is tera, and divided by S power of 3 plus 36.96K, which is kilo, S power of 2, and plus with 6883.02 mega second, plus with 6.31 tera. And for the step 1, for the step 2, which is using BLT, which the formula given 2 per T will times with Z minus 1 divided by Z plus 1. So we just need to put the value of T, and we will get like this, which is 20K times with Z minus 1 and divided with Z plus 1. So we need to, in the equation of my equation, we need to add or substitute the value of S in the equation, which will be like this. After the substitute, we need to times 36.96K with the which is the substituted answer of S, and we will get 6.31 tera divided with 80 times with Z minus 1 power of 3 divided with Z plus 1 power of 3, and it also will plus with, which means add with 40.784 tera, and times with Z minus 1 power of 2 divided with Z plus 1 power of 2, and we need to add with 30.66 tera with times with Z plus minus 1 and divided with Z plus 1, and finally add 6.31 tera. And after multiply, after that, we need to divide this equation with 8. With 8 tera. So we will get this equation after we divide with 8 tera, which is we will get 0.789 times with z plus 1 power of 3 and divided with z minus 1 z minus 1 power of 3 with plus add 1.848 times with z minus 1 power of 2 with times z plus 1 and add 1.708 times with z minus 1 times z plus 1 power of 2 with adding 0.789 times with 7 plus 1 power of 3. So for make it simple, we expand the value z minus 1 power of 3, which is equal to z power of 3 minus 2z power of 2 plus z minus z power of 2 plus 3z minus of 1, and we also expand, which is negative z minus 1 power of 2 times with the negative 7 plus 1, which we get 7 power of 3 negative 7 power of 2 negative 7, and finally add with 1. And for the next value is z plus 1 with adding with times with z plus 1 power of 2, which will get z power of 3 plus z power of 2 minus z minus 1, and finally we expand the value for z plus 1 power of 3, which is will get z power of 3 plus 3z power of 2 plus 3z plus 1. And after that, we need to apply the x, which we expand the value in the equation, which has been shown in here, 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 and here, also here. So after that, we need to multiply the equation, which we will get like this. And so for make not complicated, I arrange according to the power, which is power 3, power 2, power 1, and lastly 0. So after getting the value, which is 0.78923 plus 2.6377z power of 2 plus 2.367z plus 0.789, which divided by 5.345z power of 3 minus 0.773 z power of 2 plus 1.881 z, which minus with 0.071. With this value, I make simplify, which is using 5 0.345, we need to divide, which will get 0.148 z power of 3 plus 0.443 z power of 2 plus 0.443 z plus 0.148. And for the bit dividing, z power of 3 minus 0.145 z power of 2 plus 0.339 z minus with 0.013. So by dividing 5.345, I get the value like this. And for the final getting result, I will divide z power of 3, which I will get 0.148 plus 0.443 z power of negative 1 plus 0.443 z power of negative 2 plus 0.148 z power of negative 3, which divided by 1 minus 0.145 z power of negative 1 plus with 0.339 z power of negative 2, and finally minus with negative 0.013 z power of negative 3. And this is the last answer for determine the different equation. And for the next question is, we need to use Scilab and MATLAB to plot the magnitude and phase frequency response. So I had used Octave Online. So Octave Online, which is in my left side, we need to create the coding, and the right side will appear the result of the coding. So for the first is, we need to make the coding. For first step is clear, and the second step is frequency, which is I use in question A, which is Fs is 10,000 and Fp is 2374, which is my ID metric, last 4-digit number. And with that, I need to use butter, which in line 4, which I need which 3 Fp will divided by Fs per 2. And for the last is, it will appear of frequency for B and A, which is the right side. It will show the answer of the coding, which my Fs is 10,000, Fp 2374, and for the B is, it will appear 0.1476 with 0.4427 with 0.4427, and final is 0.176. And for the A is, it will appear 1, negative 0.145 and 0.338, and final is negative 0.013, which is the similar with the my result with I has determined using different equation. So for the next is, draw the block diagram of realization in form 2, which also I need to use the equation which I get from question A, which is yz and xz equals to 0.148 plus 0.443 z power of -1 and plus with 0.443, z power of -2 plus with 0.148, z power of -3, which will divided with 1 minus with the 0.145, z power of -1 plus 0.339, z power of -2 minus with 0.013, z power of -3. With that, I can draw the block diagram in form 2, which is as we shown in this, and the right for the left side is x equals to n with the value here. For this, it will apply at this, which is -1, -0.14 and 0.339, and finally is -0.013. For the right side, it will appear for the y value, which is yz, which is 0.148, 0.443 and 0.443, finally 0.48, and in this will be z negative power of 1, z negative power of 1, and z negative power of 1. So that's all for the block diagram. For question D, I will explain about how to determine the system for region of convergence and the stability of the system. So I have done this question by using octagon line, which is using the equation from question 1, which is 0.148, 0.443, 0.443 and 0.148 as a numerator, and the denominator is 1 and -0.15 with 0.339, and the final is -0.013. So to determine the z-plane, I have declared z-plane is shown in this with numerator and denominator, and I also use transform to z-plane, which is numerator and denominator will transform to z-plane from zpk, and I also define the source, which is zp to sos in zpk, and finally it will display as second order section and display source. At the right side, it will show the result of the coding, which is the numerator value, the denominator value, and the z values, p values, and k values, and it also will show the source values, which is here in the second order value, and finally it will display the second order section and display the source diagram, which is the stability of the system. And in this it will display which it shown the x point in 0.5 something, and the second is 0, and third is -0.5 with the x-axis is 0. It will be the result for this question. the next is, which is the 4 suitable application for this filter, which is butterworth filter, third order low pass, which is the first is current mode amplifier, which is one of the application. I can say that because according to the research paper, relation of a third order low pass using the recent current difference buffer amplifier by a current feedback amplifier, which already is proposed, which had been utilized in the design to obtain extend frequency operation in the range of 1 MHz until 20 MHz, and an additional band pass also obtained in the same topology with suitable design. That is the reason why I choose this application, which is current mode amplifier. And the second is the third order low pass filter, which the application used is WiMAX and LTE receiver in band attenuation. Which is use the GM cell employ a circuit technique which to reduce the nonlinearity of the source follower state resulting from unmatched signal swing at the gate source and source terminal of the input transistor, which GM cell used to build a bigger block which was utilized to construct a third order butterworth low pass filter. So the proposed filter also consists of buffer and a Biquet stage to form the third order transfer function. And this application is done by Unimap. And the third is using the universal filter chip. We also can design a third order butterworth filter. And the final is renewable energy application, which we can use, which we need to design of harmonic filter, which include the butterworth filter for renewable energy applications. As the summary, I had achieved all the questions with suitable answer and able to done in theoretical with using calculation, which is determine the transfer function and different equation. Also able to done in simulation using Octave Online. With the equation, I able to draw the block diagram, such as in question C, I have draw the form to realization, and final is able to region of convergence and stability of the system using Octave Online, which is I can determine the region of convergence and the stabilities of the system. As a final is, I will tell I had successfully done this mini project without any problem. That's all from me. Thank you.